Now, the COVID-19 pandemic has brought on many challenges for our society, most especially for the healthcare sector, where a mass shortage of ventilators is expected, machines which are crucial in helping the body fight off the COVID-19 illness. But where there is a will, there is a way. And that's certainly the case for the many South African inventors who recently took part in the ZA Ventilator Challenge to help develop more accessible ventilators to be used during the pandemic. Now, Nick Matter, a Durban-based mechanical engineer, and his team came out tops in the competition with their machine named the SaveVent, and he joins us to talk about the innovation and, of course, the big win. Nick, thanks so much for making the time to chat to us. Congratulations, first of all.
Thank you.
Now, talk to me about what spurred you into action and made you enter the ventilator making competition.
Well, the sad events in Italy and later across Europe, whereby the medics had to perform what they call triage, which is where they choose which patients to keep alive on a ventilator. And what they decided to do was take the older patients off. So they looked at the age of a new patient coming in needing a ventilator, and they would actually disconnect an old patient and leave them to survive on their own. So that was the strong motivation to step in and see if we could do something in providing for the lack of equipment in the medical devices field.
And you've come out with an incredible innovation, an incredible invention as well. This machine that is named the SaveVent. It's a mandatory mechanical ventilator, I understand. Now, can you further explain to us what exactly that means and what makes this ventilator so unique to what is currently being used in our hospitals?
Yes, so this ventilator is what they call a volume-controlled mandatory ventilator. So it provides the breathing automatically at a set volume. And the volume is controlled between, say, 400 and 500 milliliters per breath. The machine automatically provides that breath at a certain breathing rate, which they call the breath per minute. And that is adjustable as well as the volume on our device. And then it gives the patient a chance to breathe out after giving them the breath, so that the patient can decide when to breathe on an ICU type ventilator. Ours isn't that. Ours is an emergency ventilator, so the patient is helped to breathe. It gets the steady airflow as it is provided by the device, that's why it's called mandatory, because it automatically gives you the breathing.
Talk to me about what went through, the work process of creating this machine, because you must have worked tirelessly, having taken less than 2 months, I understand, to start and complete the prototype.
Yes, we set the objective to do the three things. One was the breathing rate at about 20 breaths a minute, and we found we could make that speed adjustable. The second was the volume of about 500 milliliters per breath, and the third was what they call the IE ratio, which is the timing for breathing in and breathing out. We took these requirements and we designed a model which I built it in cardboard so that it could have all the moving parts of the mechanism. Then we built the mechanism in metal according to the model, and we motorized the mechanism automatically with what they call a cam, and we set the IE, or the timing ratio, of the mechanism according to the cam design. So all of these requirements that Dr. Watt gave us, we built into the mechanism and the controls.
Now, let's talk about what's happening right now in terms of trials testing the efficiency of the machine that have begun at UKZN. What are the results that you are getting from there? Has there been positive feedback?
Yes. Well, we have tested it on what is known as a gas analyzer, and the device performed very well. It gave the correct breathing rate, and it gave the correct volume, and the doctors wanted it turned right up to 100% oxygen, and we found that there was 100% oxygen being delivered by the device. So we seem to have met the specifications required, but the device hasn't been through the regulatory authority testing yet.
Well, congratulations so far on what you have been able to achieve. So what comes next, and what hurdles do you still have to jump through in order to make it a viable option?
What we would need to do is we're seeking funding. We need to manufacture about 8 or 10 devices which can go through all the testing procedures and go to clinical trials in hospitals once they've been approved for use, after which we will be able to go into full production for a number. If we can receive an order, then we can produce any number of these emergency ventilators. What I want to say is that we are able to build these ventilators at 1/10 of the cost of the imported ICU ventilators.
Wow.
So being able to provide such a large number for a small amount of money is what is key, especially in our context where we don't have all of the resources like they do in Europe and United States.
Well, Nick, congratulations to you and your team thus far, and thank you once again for making the time available to chat to us.
And thank you to Expresso for hosting me.
Well, I think we all realize the impact of COVID-19 and the coronavirus pandemic on society at large, and especially on the healthcare sector. And thanks to the likes of Nick Matter and his team, there is certainly reason for us all to find inspiration.